This is problem number 1 on the sample test problems for test number 3. The 10th Fibonacci number is 55 and the 11th Fibonacci number is 89. A, what is the 12th Fibonacci number? So we should know that in order to get the next Fibonacci number, you add the previous two. So if I wanted to write that in symbols, F12, the 12th Fibonacci number, is really equal to F11, the 11th Fibonacci number, plus F10, the 10th Fibonacci number. And these are both given. The 11th Fibonacci number is 89, plus the 10th one, which is 55. Add those together, and we get 144 is the 12th Fibonacci number. Part B, the 50th Fibonacci number is about 1.26 times 10 to the 10. Find the approximate value of the 51st Fibonacci number. Okay, so unfortunately we can't use the same technique that we used in Part A, because in Part A we had the two previous Fibonacci numbers. To get the 12th number, we used the 11th and the 10th. To get the 51st number, in theory, we need the 50th, which we have, and also the 49th, which we don't have. So there's a different technique for solving this kind of a problem, and that's to recognize that if you divide consecutive Fibonacci numbers, you get that magic number that we saw before, the golden ratio. So for example, if we took 89 and divided it by the 55. This is something we did in class. We'll just pull this up on the calculator. But we should get something real close to that 1.6 and change that we kept getting over and over again in our table. And so 1.618 is a pretty good approximation for what you get when you divide consecutive Fibonacci numbers. If I did the next one, 144 divided by 89, I get something very close to 1.618. So how are we supposed to use this? Well, first thing I want to do is say what the real golden ratio is. So we called it phi. The definition of phi is 1 plus the square root of 5 over 2. And so if we type this in, we'll get around 1.618. But that's the most accurate thing we can type into the calculator. 1 plus the square root of 5. Notice the extra parentheses to indicate that all that is the numerator, and divide by 2, and we get a very good approximation for the golden ratio. And the idea is that that if you multiply that number by a Fibonacci number, for example, if I take 89 and multiply it by that number, well, I should get something really close to the next Fibonacci number. It should be very close to the 144 that we found before. And that's quite close indeed. So the trick here to find the next Fibonacci number given a single Fibonacci number is to just multiply that Fibonacci number by phi, by this golden ratio. So over here, we're going to say F51 is going to be really close to F50, the number that we have, times phi. And F50 is this 1.26 times 10 to the 10 times, and then phi is this 1 plus square root of 5 over 2, right around 1.618. So we'll type that into the calculator. So 1.26 and then times 10 to the 10. I'll use this EE thing. That's how we do an exponent of 10 to the 10. And then times the golden ratio, times this 1 plus the square root of 5 divided by 2. So if I've typed that in correctly, then we should get an estimate for the next Fibonacci number. So we'll write that here. So that's about 2.0387 times 10 to the 10.